option. Yes, I got it. Okay, recording in progress. Okay, so the oxidation and the reduction reaction of organic chemistry. Oxidation and reduction reaction in organic chemistry. Okay, oxidation and the reduction. When we discuss inorganic chemistry, so oxidation and reduction has a lot of definitions. What is oxidation? Gaining of oxygen, gaining of oxygen gas, nahi, gaining of oxygen only. Okay, so the gaining of oxygen, or you can say uh, losing of hydrogen, or losing of electron. Let me give you the example of oxidation again. Basically, we have two types of reaction, the oxidation and the reduction reaction. Oxidation means loss of hydrogen. Oxidation means loss of hydrogen. We have two types of reactions now. Every reaction could be either oxidation or reduction or redox, means there could be oxidation and reduction both. But what is oxidation and what is reduction? Oxidation means loss of hydrogen. Gain of oxygen is oxidation. I mean, you can see if something is gaining oxygen or or if something is losing hydrogen. These are the hydrogen and oxygen. ये नहीं आपने देखना कि कोई ऑक्सीजन गैस को गेन कर रहा है, बिकॉज बहुत से स्टूडेंट्स मुझे कहते हैं मिस वो एलिमेंट ने एक ऑक्सीजन को गेन किया, उसने O2 को गेन नहीं किया था, तो इसका मतलब है कि वहां ऑक्सीडेशन नहीं है. नहीं नहीं नहीं. Gain of oxygen. I haven't written oxygen gas. So what is oxidation? Gain of oxygen, loss of hydrogen, or you can say oxidation is loss of electron. जरूरी तो नहीं है ना कि हर दफा ऑक्सीजन और हाइड्रोजन आपको नजर आ जाए किसी भी रिएक्शन में. So you can see, you can check the oxidation and reduction in terms of electron transfer. इलेक्ट्रॉन ट्रांसफर नहीं समझ आ रहा और आपकी बहुत अच्छी ग्रिप है ऑक्सीडेशन स्टेट पे, so you can say increasing oxidation state is called oxidation. These are the definitions of oxidation and reduction. Sorry, this is only for oxidation, so for the reduction मैं बता देती हूँ आपको. Reduction is totally opposite to the oxidation. Oxidation is loss of hydrogen, so reduction is gain of hydrogen. Oxidation is gain of oxygen, so reduction will be loss of oxygen. Oxidation is loss of electron, so reduction is gain of electron. Or decreasing oxidation state is called reduction. Now see, for organic chemistry, let me check the reaction. Which reaction do I have here? Oxidation and reduction of organic compounds. Okay. Oxidation in terms of oxygen means gaining of oxygen is called oxidation. We did one example of oxidation yesterday. Oxidation, we did the difference between, we discussed the difference between oxidation reaction and the combustion reaction. Okay, so what is the oxidation? Let me give you some example. Let's bring a compound CCOH. The empty bonds, these bonds are filled with the hydrogen. This is alcohol. So the example of oxidation reaction is, see, this is alcohol. I am adding oxygen here. What will happen here? The compound will be C, 1, 2, 3 hydrogen, C, double bond O, H, plus water. This is called oxidation. It was alcohol and it has become, can anyone tell me what is this? Aldehyde or the ketone? Can anyone tell me if it is aldehyde or the ketone? If someone could recognize the functional group, is it aldehyde or a ketone?
It's an aldehyde, right?
Exactly, because ketone is very similar to the ester. Okay, you are absolutely correct, Ifa. This is aldehyde. Okay, so what will be the name of the compound? हम name भी यहीं discuss कर लेते हैं ताकि आपको chain के name भी देना आ जाए. 1 2 ethanol, aldehyde al, ethanol. It was ethanol. An oxidation of ethanol will give you ethanol. So if there, for example, if there is a question in your paper that oxidation, for example, if they ask you how can you make aldehyde, or if they ask you what will be the product of oxidation of alcohol, simple. If you want to make aldehyde, you can do the oxidation of alcohol, or oxidation of alcohol will give you aldehyde. This is the simple. The reduction reaction. Okay. See the reduction reaction. Reduction. This is your past paper reaction. Reduction means gain of hydrogen. This is a part of your past paper. The reaction which I'm telling you, this is from your past paper. This is CH3CHO. CH3. This is CH3 CHO. Okay, this is aldehyde. Okay. Plus hydrogen gas means aldehyde is going to gain hydrogen. Means aldehyde is going to be reduced. Okay, so this is the example of reduction reaction. Okay, reduction of aldehyde will give you, let's see what we are getting. 1 carbon with 3 hydrogen. Okay. 1 more carbon with 1 hydrogen, 1 hydrogen, and there will be OH. This is ethanol, alcohol. So that's how you have to learn. The oxidation of alcohol will give you aldehyde. The reduction of aldehyde will give you alcohol. The oxidation of alcohol will give you aldehyde. The reduction of aldehyde will give you alcohol. This is your past paper reaction, and you have to learn it as it is. Other than this, hybridization in organic compound is very easy. I mean, I have told you the trick of hybridization. मैंने पहले एक ट्रिक बताई थी hybridization की to count sigma in the pi bond. It would be very easy for you. Instead of making some resting state and the exciting state, better है कि आप trick पे काम करें. And what was that trick? Hybridization can be calculated by counting sigma bond and the lone pair. Yes. Sigma plus lone pair. You will get the hybridization. Hybridization हमारे पास कौन सी है? sp, sp2, sp3. So if the sum of lone pair and the sigma bond is 2, means 2 orbital, means sp. Simple. Sp means 2 orbital, sp2. Sp, what does sp2 mean? Wait, let me write it like this. Sp means s plus p, 2 orbitals. sp2 means s plus p means 3 orbital. sp3 means s plus p plus p plus p means 4 orbitals. 4. So if the sum of sigma bond and the lone pair is equal to 2, means sp. If the sum of sigma bonds and the lone pair in a given thing is 4, it means sp3 hybridization. So it's better to do hybridization like this instead of doing the resting state and the exciting state, or फिर उसके pi bonds check करना, फिर उसके फिर ये check करना कि कौन कहाँ जाके bonding करे. That will be more difficult. So this is easy. वैसे भी 1 और 2 mark के question है, उसमें ये exciting state और resting state में कहाँ आप लोग अपना time waste करेंगे. CH4. अच्छा, hybridization किसकी find करते हैं? The central atom की. Carbon is the central atom in organic chemistry. If there are 6 carbons, so every carbon is central atom, and you have to find hybridization of every carbon separately. Okay. So what is the hybridization of carbon and methane? There is no lone pair in carbon. अच्छा chemistry में central atom is sorry organic chemistry में the central atom is carbon. A carbon doesn't have any lone pair. It means you have to count sigma bond only. जितने sigma bonds होंगे वही hybridization number होगा because organic chemistry is based on the carbon and carbon will be the central atom and carbon will never have lone pair. हमने कभी carbon में lone pair नहीं देखा. So hybridization is very easy in organic chemistry. See, every single bond is sigma and every first bond is sigma. I mean, if there is a double or the triple bond, so the first bond will be sigma, the head-to-head overlapping, and other one will be the pi. 1 sigma, 2 sigma, 3 sigma, 4 sigma, sp3. मुझे कैसे पता 4 sigma means 4 means 4 orbitals, so 1s, एक और तो s नहीं हो सकता ना, तो p और p, sp3 hybridization. This is very easy to find hybridization in organic chemistry, and it is also easy in inorganic chemistry too, if you use the tricks instead of doing that all stuff like exciting state or whatever the thing is. Well, लेकिन मैंने वो भी सिखा दिया था आपको exciting state वगैरह, और before the exam में एक दफा और बता दूंगी. Okay, let me show you one more. For example, there is ethene. This is ethene. If they ask you that what is the hybridization of carbon in ethene, so there are 2 carbon and you have to find hybridization of both the carbon separately. So for this carbon, 1 sigma, 2 sigma, then there is a double bond. Between the double bond, there is 1 sigma all the time. So 3 for this and 1 sigma, 2 sigma, and 3 sigma. So 3 for this means sp2. So both the carbons are sp2 hybridized in ethene. But let me tell you one more thing. In organic chemistry, you have to focus on the shape of molecule also. There is no lone pair. So I cannot make hydrogen like this. No. There is repulsion between the bond pairs. So hydrogen should be like this all the time. You have to make shape carefully. You have to make ethene like this all the time. For example, there was a chain in your exam like this, and you have to fill the hydrogen. So see, for this carbon, you have to fill hydrogen like this. Tetrahedral. This is tetrahedral. No lone pair. Symmetrical tetrahedral. Central one cannot be discussed like in shapes, but the corner one, I mean, we have to discuss the corner carbons when we are discussing the shape of molecules. So first carbon, second, and the third one. See the third one, only 2 hydrogen like this. So the first carbon has tetrahedral structure. The last or the third carbon or the right carbon, it depends from where you are counting. I mean, we have to count carbon from here because the double bond is very near from the right side. Well, so this carbon, this one, okay, this carbon is having no lone pair, 3 bond pair, 1 bond pair, 2 bond pair, 3 bond pair. So all should arrange at equal distance or at equal angle to minimize the repulsion. There is no lone pair, so the shape will be symmetrical, that is trigonal planar, and the angle will be 120. So when they will give you any compound to make the skeletal formula, to make the structural formula, or something else, or something, they will give you some skeletal formula, and they will ask you to make the display formula. So they will ask you one more thing: what are the shape of that carbon, and what is the bond angle? So you should know all this stuff for organic chemistry also. So to check, the hybridization number is easy, and shapes of molecules are also easy. There will not be any pyramidal something or the band structure in organic chemistry because carbon will be the central atom. It doesn't have any lone pair. Whenever there will be lone pair, then we get something band structure. So there will be either tetrahedral, or there will be shape like trigonal planar. I mean, we have 2 shapes in organic chemistry, either tetrahedral or trigonal. Okay, other than this, one thing more, the polarity. Okay, let's discuss the polarity, then we can end the class. Polarity in organic compounds. Methane. Let's see if it is polar or not. First of all, you have to see if the compound is symmetrical. Carbon doesn't have any lone pair. This is a symmetrical compound like tetrahedral structure. Which one is electronegative? No one. We never discuss carbon in electronegative elements. We never discuss hydrogen in electronegative elements. Okay. But still, the carbon is more electronegative as compared to hydrogen because carbon has more nuclear charge, you can say. So we can say that electron, the electron of hydrogen is moving toward the carbon. Carbon is more powerful, you can say. So carbon is holding for nanosecond. Carbon is holding the electron of hydrogen for a nanosecond. This is the first carbon, first hydrogen. This is the second hydrogen. So its electron will also be held by the carbon. These arrow means the dipole movement. Polarity means the pole, the positive pole and the negative pole. These arrow means these arrow are telling you the direction of electrons, where they are moving for the longer period of the time, where electron is staying for the longer period of the time. These arrow means the dipole movement, the movement of electron. And see, see this one and this one, both are opposite in direction. Cancel. No dipole, no polarity. This is the polarity in organic compounds. See, this is third hydrogen, this is fourth. So electrons are moving like this. These are the dipole movements, which are telling you about something about the polarity, but they are exactly opposite to each other. Cancel. All the dipole movements are cancelled. No polarity. Compound will be non-polar. But see, this is carbon. One more carbon. This is hydrogen, this is hydrogen, this is hydrogen, and there is O and there is OH, carboxylic acid. So oxygen is more electronegative. So it is holding the electron of carbon. So we have to show dipole movement like this. And there is one more oxygen which is more electronegative as compared to hydrogen and carbon, and that is holding the electron. See, these red one are the dipole movement, which are telling you that where electron is being holded. And these both cannot cancel each other. They are not exactly opposite to each other. They should be like this. Then we can cancel them. They are not cancelled. So this end is polar, or the compound is polar. What is this? Carboxylic acid. Carboxylic acid is a polar molecule. So this is the polarity in organic chemistry. This is simple actually. Let me check if there is more in a polarity. Is there any other compound? No. Oh, wait. Okay, there is no any other compound which should be discussed in polarity. So basically, let me tell you the example from inorganic chemistry also, so that there should not be any confusion. For example, HCl. Hydrogen is sharing its one electron to the chlorine, and everyone knows that chlorine is more electronegative. So electron from the hydrogen is moving toward the chlorine. This arrow is showing the dipole movement, the movement of electron, you can say. And there is no other dipole movement which can cancel this. So the compound is polar. For example, carbon dioxide. This is the structure of carbon dioxide, everyone knows. Oxygen is more electronegative. So oxygen is holding electron from the carbon. There is one more oxygen at the left side. It is also holding electron from the carbon. These are the dipole movement. The compound should be polar, but both the dipole movement are exactly opposite to each other. Cancel each other. For the cancellation of dipole movement and to make compound non-polar, the compound should be symmetrical. See, it is symmetrical, the linear structure. You cannot cancel dipole in non-linear or in a bent structure. For example, H2O. See, Oxygen. Oxygen has two lone pair, na? So they will repel the bond pair. See, this is water molecule, the red one. Oxygen is more electronegative, so it will hold the electron from the hydrogen. These are the dipole movements. They are not opposite to each other. For the opposite one, see the blue one. It will be opposite to each other, then I could cancel them. So dipole movements are not canceling each other. So the water molecule is polar. While carbon dioxide should be polar, but there are dipole movements due to the symmetry, due to the shape of molecule, both the dipole movements are canceling each other. So the compound is non-polar. I mean, there are a lot of students who are confused that why carbon dioxide is non-polar. Oxygen is second most electronegative element. We have three most electronegative element in a periodic table: nitrogen, oxygen, fluorine. Oxygen is second most electronegative element. It is holding electron from the carbon. Why carbon dioxide is not polar? Reason? Carbon doesn't have any lone pair. So the shape of molecule is symmetrical, exactly linear. That's why the dipole movements are canceling each other. So the compound could be non-polar. So whenever we are discussing the polarity, first you have to check the shape of molecule. No. First you have to check the electron negativity difference. Then before declaring the compound as polar and non-polar, check the shape of molecule. If the dipole movements are canceling each other, means the compound will be non-polar. This is the most repeated question in your past paper. They can ask you like why carbon dioxide has a linear structure and why water has a why water has a bent structure while carbon dioxide has a linear structure. And they may ask you that carbon dioxide has two oxygen atoms, while water has one oxygen atom. Oxygen is second most electronegative element in the periodic table, but still, water is polar, but carbon dioxide is non-polar. So you should know about the dipole movement, which are canceling the polarity in a compound. That's why carbon dioxide is non-polar due to its linear symmetrical structure. There is a trick. All the asymmetrical, like bipyramidal or bent structure, non-linear structures are polar because the dipole movements cannot be cancelled. Simple. This is a trick. Okay, so this is all about the polarity. I guess this is enough for today because I guess Sabur is taking class with me since 8. You all can join me at 8 p.m. tomorrow also. Actually 8 p.m. Pakistan पर ना सूर्य की class होती है. She's taking individual classes, but she's little weak in different subjects, so she's starting from the basic of the chemistry. So you all can join me in her class also. You can keep your mics off, or if you have any confusion, you can ask me anytime. So you can revise the basic things of the physics, whatever she's studying with me. So you all can join me tomorrow at 8 p.m. also, or if you don't want to join with her, so you all can join me at 9 p.m. Pakistan time in a group class of chemistry. I guess we should continue with the chemistry because let's complete the organic chemistry. It has a lot of details. It has a lot of reactions. So let's complete the organic chemistry because on a weekend, I'm planning for the bio class, the longer class of the bio. I'll tell you the topic a day before. We could cover more than half chapter in a class. I'll let you know. I'll let you know the timings. I'll discuss with you. I'll plan the class when all of you are available easily. So inshallah, see you in the next class. Do you have any confusion in the topics which we have discussed? Yes, Sabu, do you have any confusion?
No, miss.
Okay. Ifa and Hira, do you have any confusion?
No, ma'am.
No, miss.
Okay. See you inshallah tomorrow. Take care. Allah Hafiz.